All right, so for lab 4, I'm not gonna give you any result for the experiment, but I did all the lab on the camera. It was all recorded. My hope was for you to watch the video and fill in the lab report. The lab report is very descriptive, I mean qualitative, so I thought probably you would enjoy this. Okay, let me show you the video and the lab report and the empty lab report, and I'm take it from there. So I recorded this on day 2 of recording. No, where is it? Day 3. Lights and circuits board. It's a very easy experiment and very nice. Okay, this is my first video that is as large because I'm not gonna move the view, it's on the board. All right, before we start, let me open the manual. Yeah, so the manual, I'm gonna open the PDF because it's faster to open. This is the manual. And I'm gonna scroll, it's already open. I'm gonna scroll down to experiment 4. So you have circuits and bulbs. They tell you what the equipment are. You have the circuit, the actual circuit. You have a D-cell battery that I'm not gonna use. You need wires, you need a paper. I don't know, let me show you a bit of what you need to do. I did the procedure, so I'm not gonna go there. 1 second. So go over this quickly before you watch the video. Okay, so this is the lab report. Question number 1, connect one light bulb to one D cell in such a way that the light will glow. So I'm gonna do that and the light will glow. Sketch the circuit in the table below using straight wires and correct symbols. All right, now in the first page of the manual, they show you the symbol of a bulb. So basically it's a circle with an X inside or a circle with a signal inside. So use anything you want. When they say sketch the circuit, just use straight wires. Make sure your circuit is straight, like a rectangle or a square, not a weird shape. It's not a drawing or not a picture. It's a circuit, okay? And I'm sure you know how to do that since grade 7. And then they ask you what happens when you reverse the 2 wires. I'm gonna do that on the video and you can answer the question. Now construct a circuit with 2 light bulbs. Try 2 ways. I'm gonna try it on the video. So you see it's all descriptive. They want you to compare and explain. So no measurements needed in terms of values. And the most difficult part in this circuit is to observe the brightness of the bulb. That's why I made sure not to move the camera at all. All right? And these are extra questions you can answer, not related to the experiment. Okay, so very easy, very short. Usually students do the experiment and the lab report, all of it in 90 minutes. Now let me show the video. This is the circuit board. I can put it a little bit bigger. Chris is asking if the deadline of the lab is tomorrow. Chris, I have no idea. Usually I go to Blackboard and check. Do you think Blackboard is giving you the deadline? Does it show? Okay, please follow Blackboard because I write it there. Okay, it says, all right, if it says Tuesday 11:30 p.m., go ahead. Okay, I don't remember why it's Tuesday 11:30 p.m. Probably some of your friends asked for extra time, all right? Because you know, for every section, it's gonna be different. I mean, section like for physics 111 and physics 201, sometimes, yes, I know, I totally understand you have some adjustments. All right, so if you, yes, take your time for that. If you see this board, you see the bulbs. So this is bulb number 1, bulb number 2, bulb number 3. This is a switch that I'm not gonna use. This is a transistor socket. You put the transistor here that I'm not gonna use. This is a rheostat. By mistake in the video, I said thermostat. Thermostat varies with temperature. So it was like a wrong thing I said. So it's a rheostat. By turning the knob, you will vary the resistance of this guy. By the way, it has 3 legs. I'm gonna use the first leg and the second leg. And by turning the knob, the resistance between terminal A and B would vary. I'm not gonna use the sockets for the dry cells. I'm gonna tell you why. Because the dry cells, those big ones, the EMF of which is 1.5 volts, are not to be trusted. I don't trust them because every time I move the dry cell inside the socket a bit, it's gonna give me a different voltage. And sometimes it doesn't push enough voltage. Like every time I change the circuit, it gives me something else, you know? Instead, I use, you see those wires? They are connected to my power supply. And I have a voltmeter connected to my power supply to show you that the terminal voltage, which is 2.85 volts, is gonna be constant throughout the experiment. I want to see constant because when the brightness varies, I want to make sure it did not vary because of the voltage. The batteries sometimes would give me 1.5, sometimes 0.8, and this is really misleading. So instead of batteries, I use this connected to the power supply. Just imagine this to be your battery, okay? And then I'm gonna use extra wires to connect to the bulb. What else? I'm not gonna show you the whole video, just the simple connections, just for you to feel what's waiting for you. So let me show you. I'm removing my earphones. Yes. This experiment is called light and bulbs. As you can see on your screen, you have the AC/DC electronics lab kit. So what is this basically? You have here two sockets on which you can put dry cells, those big dry cells of EMF 1.0. Okay, so this is repetition. I'm not gonna repeat it. You can watch it later. I'm gonna show you the first connection. Bulb. I don't have batteries and I do not trust batteries. What I will do instead, I will take a 3 volts DC on my power supply. So there is a power supply in here that is outside the picture. I don't know if you can see it. It's a little bit heavy. So this is the power supply I'm using. The power supply is basically connected to the board through those wires, and I connected in parallel with the power supply this voltmeter just to show you, to keep track of the voltage given. All right, anybody can tell me why I'm targeting 3 volts? Anyone? Why do you think I would want to use 3 volts on my board? Any idea? How much is each dry cell? The big ones.
Isn't it 1.5 or I'm wrong?
Yes, it's 1.5. So why use 3 volts? Can you guess?
You're using an equivalent?
All right, so basically in the previous experiment, like how it was given from Pasco, they wanted us to use dry cell 1 connected with dry cell 2 in series, you know? So to add the voltage to 3, because 1.5 volts is too little and the bulb will barely give you some light. So we usually connect the 2 dry cells together to give 3 volts for the bulb to be shining well, you know? So here I couldn't get 3 volts. So every time I touched the power supply, it would give me 3 and then drop down to 2.8. So I'm gonna use 2.8, which is enough as long as it's a constant, okay? My board. I wanted initially to have 3 volts. Okay, now let me show you the first connection. Easily move it to 3 volts. I don't have to be super precise. As long as I'm very close to 3 volts, it's gonna be enough because it's gonna change throughout the experiment. Before I start the experiment, I want to make sure that my 3 bulbs are functioning. So I take the terminals of my power supply. Oops, let me do it. Okay, and I connect them across the first bulb, functioning, second bulb, functioning, third bulb, functioning. These 3 bulbs should give you exactly the same brightness. And you will have to do a lot of observation on this video and to fill in your lab report. If you see that the brightness is a little bit different, it could be due to many reasons, although the bulbs are identical and the total voltage is identical, and you can always read it from here to keep track of what is the input on your board. Okay, so 3 identical bulbs, same terminal voltage, you should have the same brightness. I will put my voltage back to here, and now the main question is what brightness depends on? Voltage, current, both, I don't know. So this would be the main question for this lab report. every time I need to connect to the bulb, I'm gonna use those very thin wires to connect the output of my power supply to the bulbs. Now let's go back to the lab report and read the questions. And you have to fill in the lab report while we go through the video. Okay, this is the first connection from under the board. And I'm gonna connect this to this one. Okay, done with the question. They asked me, can you imagine how cool this experiment would have been on campus? Like, check it out. When the light goes on, it's really interesting. It's really exciting. I don't know if it's equally exciting on the video. You guys, are you going to the on campus for other labs?
No, all of them are online.
Okay, what is the reason? Is it that the instructor cannot take the risk? Well, I
Doctor, I didn't hear your question.
Say it again, Michelle.
Could you please repeat the question?
Okay, so my question is, how come you're not trying to go on campus for other labs?
I don't know, probably because of the condition.
Okay, I'm just
getting worse.
Yeah, I know.
Doctor, it's safer because Al is only getting worse. There's nothing that indicates it's better.
Yeah, I know. But since you guys asked to be on campus for physics lab, how is it different? I'm just trying to understand.
Genetics lab, he did mention that he will tell us later on if we will be back on campus and when, or he will give us updates with time.
Yeah.
So,
but would you want to be on campus for the genetics lab?
Personally, I know that the experiments are pretty interesting, and I would wanna be there. I would take my precautions, Saraha. No.
Okay, so that's for George, and for the others, are you interested to be on campus for the other labs?
Doctor, I'm interested in being for the labs, but if it's like once or twice a week, I live pretty far from you, so like getting there, the transportation would be a little bit hard.
Yeah. So you want to try your best to make it efficient.
Yes, if like all the labs could be together, like in something, find something common, so we don't have to go a lot.
Yeah. All right, just a question.
Doctor, Anna, personally, I'd rather not, Saraha, with everything happening, cases, widespread. It's now like everybody knows at least one person who has it. So no, it's...
Yeah, you'd rather stay home and do the experiment online. Yeah, I totally understand. Okay, so just a question that popped to my head. I'm gonna anyway send you an announcement and wait for a feedback and make it clear to you. All right, we'll try my best. So now for this lab, as you can see, I'm showing you each and every step. It's not a long video though, it's 10 or 11 minutes. So I tried my best to be super quick. You will watch the video, you will fill in the lab report, and let me know if you have any question. I think that's it, okay? So I'm gonna show you in a bit how the series connection is gonna happen. So this is a parallel connection. You see the brightness of both. I'm gonna remove the parallel connection so you can compare before and after, you know, for the brightness. And this is a series connection, so you can compare before and after. So it's not super bright, like the parallel one is brighter, right? So I think by going forward and backward in the video, you can tell exactly what's going on. It's an easy experiment. Yes, Joe, it's okay. So the video, I think, will be enough. And as you observe the voltage, how it's changing, it's not changing. It's basically fluctuating on the second decimal, isn't it? But it should not affect the brightness of the bulb. Okay, so that's it for lab 4. I'm happy that lab 4 is somehow a bit chill, because you had lab 1 difficult, lab 2 even more difficult, and then lab 3 time consuming. So this is at least will give you a break to breathe. Yeah, and that's it. I have nothing to add, and I'm not gonna keep you longer unless you have questions. Any question?
Thank you, doctor.
Yeah, so enjoy your day. Finish up lab 3. And I'm gonna give you a regular deadline for lab 4, which is a week from now. So hopefully next Monday, during the time of the lab, if you guys are okay with that. Yes, somebody has a question. Was it you, Anthony?
I have.
Yes,
As for the, can you post if you finish the correction of the second report to see our mistakes, not to repeat them in this third report?
Okay, yeah. So you want your lab report number 2, so you make sure you don't have the same mistakes for lab report number 3. Okay, so I'm gonna try to finish them tonight before the deadline of lab 3, which is tomorrow. You can end at any time, unsubmit and submit again, in case something like a mistake you usually do, okay? All right, Joe, any other concern? All right, I'm here if you need me. Just let me know.